Thank you, Carsten. As I mentioned earlier, there is a change slightly in the agenda that you've got in front of you, and George is going to be presenting on IndoorGML on behalf of Ki Jun.
I will try. There's actually probably some folks in the room that know IndoorGML better than I do, so you can correct me when we get there. But Ki Jun did send some slides. I've made some modifications and the like, but it's, I think, very relevant to what we're talking about here in smart cities. So IndoorGML, brief introduction to the standard itself, but also give some examples of how it's been applied. So one motivating factor is that most of our time, 80%, 90% of our time is actually spent indoors. This is one of the statistics that's mentioned about why LBS hasn't taken off as much as you might have expected, and the need then to be able to do the kinds of things that we do outdoors to be able to do indoors. Navigation, knowing where you're at, where things are at, being able to move around, what have you. So it's also a great motivator for, there's another version of this that gets after retail and marketing and the like, and being able to incentivize people, especially in a shopping environment, to be able to go to a specific offer or what have you. But a lot of our time is spent indoors, so how do we deal with that? The goal of IndoorGML is to represent and allow for exchange of geoinformation that's required to build and operate indoor navigation systems. So actually what you saw from CityGML is it has a significant indoor portion, level of detail 4, includes a walkable indoor environment, and so is very critical for meeting this need of indoor spaces. The key thing that IndoorGML brings is the navigation. We'll get into some of this geometry versus topology discussion, as a matter of fact. The difference between geometry and the space representation, and how do you actually get from here to there, which is the topology question. Ki Jun cautions us to use the right name. So this is probably also one on the hit list of Denise. Use the right name. It's IndoorGML spelled this way, not IndoorGML spelled the other way. Very much like CityGML. It's been approved as an OGC standard back in September. Final edits are being prepared, and I imagine it'll be published here. It's not on the website yet. I'm not sure if somebody in the room has a good estimate of when it will be published on the public website, but it's available, as a final version. So, IndoorGML exists. What does it do for us? It gets after some of these applications, and I guess this is going to build. So, Indoor Geo Portal, Indoor LBS, so navigation, turn-by-turn navigation inside. Is very much doable, achievable. Now we need to do it in an interoperable, open fashion. We need the indoor venue maps, a lot of which are coming from Indoor Commerce. We're able to make sure that we cover the emergency situations. Emergency controls is one motivation for indoor venue maps to become public data, is emergency response, emergency control, emergency, sending firefighters into the right place, for example. Services for handicapped persons, so differences with respect to that route on Indoor LBS about what is a walkable environment, and different modes of transportation within an indoor environment are critical for different approaches to how you're going to navigate, and not only from that point of view, but also from the, if there's a fire, don't take an elevator point of view, right? Change the directions. Indoor robots, big connection with that community. Not only fixed locations, but also indoor locations that might be movable. So here's a cruise ship, right? You want to be able to navigate inside of a cruise ship. In hospitals, you actually see one of the major applications we'll see of a European FP7 project is in a hospital environment for use of IndoorGML. IndoorGML complements other standards. I just mentioned the relationship to CityGML, about CityGML providing the geometry. We'll actually see that in a little more detail in a second. KML, visualization of spaces using KML. KML is all about visualization. IFCs and other BIM models and the like that are needed with that. IndoorGML brings what's called a cellular space model, and I'll give you some concepts to go with that phrase in just a second. It also talks about networks between the cells, so the topology for the routing, and also multi-layered space environments so you can see what is the radio footprints of beacons and Wi-Fi and everything in indoor. One thing to note is indoor positioning is out of scope of IndoorGML. A little bit of an aside, we had a workshop about 2 weeks ago with a group called the In-Location Alliance. And so this is a group that already exists, really focused on this indoor positioning question. And we got the OGC folks and the indoor location people in the room, and for them, the only thing that's really important is indoor positioning. That's it, you know? The hardest problem to solve is the GPS inside problem, and if we could solve that, everything would be fine. And for us, the OGC people was like, yeah, you're going to solve that, right? You're going to tell us where we're at, and then we're going to be able to make use of that because we've got all this great map and spatial information, because otherwise your position's kind of useless, right? So we kind of had to get over this cultural difference between the people that are all about finding where the indoor position is at and the people that bring you that spatial information, the semantics of the space. And in the end, it actually worked out pretty well. You could see in this workshop where the perspective of the awareness of each of our own SDOs and standards and pilot use cases and what have you kind of came together. But it was interesting to see this, you know, we are all about this, we're not about this, and they were all about that. So, you know, that's going to get solved. You will have the equivalent of GPS for indoors. Hopefully is ubiquitous, right? So, you know, just to kind of put a fine point on that, IndoorGML then works with these other standards for these applications, indoor LBS, navigation in particular, robots, cameras, services for handicap, emergency control. It's kind of a redundant slide, I'm not quite sure what more that adds, but keep June. So let me get a little bit into the standard, and this may scare some of us. We now have mathematical equations on the slide, so beware. Let me help you through this. So this is the notion of a cellular space model. For those that are graphically inclined, each of these grapes is a cell, and they're a space-filling cell, right? Set of all of these cells go together to make up this bunch. And so now you have a space that's defined by the bunch of grapes, and it's partitioned by these cells. Each grape is a cell. And so that's what this mathematical equation says, right? So any one cell, this is a cell that's the ith cell and the j cell, whatever, and they don't intersect. So these are all separate. There's no space inside of this bunch that is included in this cell and that cell. So they're definitely distinct, discrete cells. And the other thing is that if you take the union of all the cells, you get the universe of space that you care about. And so the union of all of these grapes is the bunch of grapes. Okay, so that's the metaphor that goes behind IndoorGML as a cellular space model. And you know, that's it's nice to know. Why do I care? It helps us to do the things about geometry, topology, multi-layered space structure, and semantic. Hopefully that makes a little bit of sense. Geometry then, let's go through each of these. In the geometry, we've got CityGML. CityGML is geometry. Its volume is important. The space is defined by how big it is. And it's just about how it's connected based upon that you've got one set of coordinates next to another. That's the geometry definition. And IndoorGML, then you're going to connect to those geometries in a variety of different ways. Essentially, IndoorGML can either point to a city GML geometry, so it doesn't actually include it in the Indoor GML, it points to a city GML model. There's some geometry that can go in Indoor GML, or you might have no geometry whatsoever. In fact, this is one of the areas we needed an action coming out of that in-location workshop I spoke about, is that we presented these options to these folks, but we didn't give them any methods to decide. We said, here's 3 options, you probably want to choose one. And they said, well, which one would you choose, right? You know? So it's up to us as the experts on Indoor GML to actually give guidance about how to do that. That's something I don't think's been talked about too much, and it's really between the city GML and the Indoor GML guys to get together and figure that out and give guidance to the people that are using it. Topology. So we've got the geometry side, which is all about space and volumes and areas and the like, and then topology, which is all about connectedness. And there's some crazy theory, there's actually another picture that goes in here about some historical people that came up with this so-called duality. In any case, it allows you to go from some space to this other representation. So a solid is actually a node, and then a node becomes really important in this connectedness. So here on the left is more the geometry side, and you define a cell. So here's our grapes, right? This is 2 grapes that make up this bunch. Grape 1 is cell R1, and grape 2 is cell R2. And so you can look at it from this perspective of space and area, or you can say, okay, cell, I know that's exactly this, cell R1, cell R2, and I can turn those into nodes. So that cell R1 is R1 here, and cell R2 is here. And now I don't care about how big those spaces are. What I care about is how they're connected to each other. And so then the lines actually show that you could go from room 1 to room 2 or to the external. And so the key for navigation is that this is this graph, this dual space, helps you to do navigation. So a whole bunch of math concepts that allows us to walk from room 1 to room 2. It's pretty easy for us. We got to teach the computers how to do it. This is the information model that computers use to do that, right? So geometry, topology, semantics. Semantics of the indoor space. That's important for navigation. You walk through a door, you don't walk through a wall. Those kinds of things. At least, I don't know, I've seen some superpower guys walking around here in Akihabara that probably would walk through walls, right? Sorry. Semantic interpreted indoor space, definition of attributes, key to understanding the spaces of semantics. One example is this notion of multi-layered space, that you've got a couple of different space models. You've got kind of the walkable space, and then you've got the footprint of the radios that broadcast in that area, whether it's Wi-Fi or beacons or whatever the technology is. It's some kind of, I think it's always been, well, it can be infrared kind of stuff too, matter of fact, infrared, right? So you could do a space model like this about the footprint of these infrared beacons. I'm not actually sure which way it goes. Well, it must be the base broadcast of this thing. And so you would know that you know, this beacon that's in this room covers this room, versus if I go out there, the beacon out there would be in that room out there. And you have to know the overlap between those to make sense of the data that you're collecting, like with these devices that are around our necks. I don't know, does this add anything more? It's the same kind of concept. Shows a relationship between the nodes in each of the spaces and how they relate to each other. I don't know, that just twists my brain. More examples about the same thing, kind of what I just said. Different spaces have different nodes, and the nodes relate to each other. Semantics are important. You walk through doors. Okay, so hopefully that is at least a basic understanding of Indoor GML, and I didn't kill it too much. You all correct me at in the question. So let's give some examples. Back when we met in Seoul, a year ago or more, the OGC meeting was in Seoul. There was a venue map service that was deployed in the convention center COEX. in Seoul, and it included an indoor map, POI data, network data, the topology of the connectedness, as well as the space data, and there was an app that was used to do this LBS, indoor navigation, an early prototype of the Indoor GML implementation of the standard. So we got that implementation. Ask Key Jun when he gets here later today or tomorrow about that one. There's a project going on right now in Europe called iLocate. Some of you have met Giuseppe Conte, who is the leader of this project from Trilogis, and they're all about overcoming these 3 barriers, creation of a public geoportal for indoor map data, so creating an indoor map. They're producing some tools for the iLocate toolkit to enable the location and tracking, privacy and security policies, and they're going to build mobile clients. A key thing here is about how they're going to provide tools to people to build indoor maps to be able to provide the data that goes into this. So creating that indoor data, indoor venue map is a key need. We need the maps for indoor, and we need them to be created easily. They're aiming at 3 scenarios. This is the hospital one that I mentioned. And not all of their applications, but many of them are focused on hospitals and health facilities. It could be like an elderly care facility, I know is one of them. So scenario 1, guidance of patients through a healthcare path. Tracking of assets is scenario 2, and guiding visitors to reach indoor locations. Actually, there's a better list there. Hospital, public office, museum, technopark. They've got like 35 different locations. They're going to deploy this pilot technology within the single project that has a bunch of members of the iLocate consortium funded out of FP7. One of the key things of iLocate is to make use of location-based standards, City GML, Indoor GML, and a variety of others. They're working with a variety of the communities that you can see there. Okay, so the third example then really is this in-location alliance. I mentioned a little bit before, and these were the topics that we had to identify potential joint activities for the shared objectives, discuss the value of technology to the end users, develop a rationale for joint activities, member experts from relevant working groups. This was our agenda overview. This was get to know you, get to know me kind of thing of the organizations coming together. There's a great quote by David Shell, the OGC founder, that says something like, interoperability seems to be a technical topic, but what it's really about is people getting together and discussing where they have common interest in information. So this was a great example of that, the OGC and ILA organizations and people getting to know each other's use cases and requirements coming out of the mostly in-location alliance folks. The architecture for the ILA system looks a whole lot like, if you remember, the OpenLS standard that is still an OGC standard and used by various people. The architecture behind the Open Mobility Platform was presented, actually, Steve Smith presented that, and we could map quite a bit between that and the ILA, except for the walled garden kind of falling down, and the opening up of that environment was a big change, right? City GML was presented by Steve Smith. Indoor GML, Stefano Pfeiffer, who is CTO at Trilogis, he's part of the iLocate. I did open POIs. We need more activity on open POIs. If you're interested in open POIs, come talk to me. We need to get that really moving. iLocate overview then by Giuseppe, and we walked away with a set of actions and reports. I will present the details on that to a session on Thursday. I forget which work group it is. So that's the Indoor GML standard, roughly, and 3 examples of application. It's relevant to smart cities because there's a whole lot of indoor spaces in smart cities, highly relevant, and we spend most of our time indoors. So Indoor GML. Thanks a lot.
Right, okay, got
hand up first?
You can absolutely stick your hand up first. So we'll start first of all with any questions for George in relation to IndoorGML. But there is actually half an hour or so now that is available to kind of have a general discussion, and I'm curious to hear people's thoughts that have come out of this morning's sessions. Really curious to see anybody's pictures and their lists and so forth, and certainly would like to put some up on the wall if you've got them there to share. But I'll hand over for a first question for George.
Sorry about that. The only reason I wanted to say, actually I wanted to make a statement because I represent ILOCate here.
Okay.
Sorry.
Oh, sorry about that,
Yeah. No, that's okay.
Hope I did okay.
And you are absolutely perfect. It was just to let people know that we actually are looking also for liaison so that people, I mean, this is not heavy stuff, it's meant so that you can know what's going on in Europe in the ILOCate indoor-outdoor field. So I'm here all week. If anybody wants to give me their business card, I will then send you a simple piece of paper that says, I want more information, and we will keep you informed. So that's the first thing. The second thing is, tomorrow morning on the urban planning meeting, no, is it tomorrow? Yeah, Wednesday morning on the urban planning, I have the great privilege of doing what George did and have to present two of Conti's concepts. So if you want to know more about the extension of this, then come along to the urban planning meeting tomorrow. But thank you, actually, I think that was brilliant. I think you put yourself down, it was great.
That's good to hear. Making that connection, that's great.
Any other questions for George?
Somebody's going to debate my grapes metaphor? Come on.
I like that, actually.
Yeah. A spatial presentation that's got grapes is way
Did that
impressive.
help, for spatially and visually?
There's a picture of grapes on my picture up
there you go, all right.